Welcome to Algebra 1. The learning goal for this episode is to learn how to graph a linear equation by making a table of values, then plotting and connecting the points. Let's look at some examples. In order to help us create a table of values, we typically solve these equations for y first. It's important to understand that we don't have to do that. We could simply substitute in values for x or values for y and solve for the remaining variable. But solving for y first makes the process easier, and later in this unit, having equations in the form y equals an expression allows us to understand more about the linear equation. So, in this case, we add 3x to both sides to isolate y. Now we create a table of values. We can choose any value of x we want, then evaluate the expression 3x plus 2 to figure out what y is equal to. We generally try to pick a relatively small number, close to 0, that we think will be easy to evaluate. I've decided to pick negative 2. It's important to understand that you can pick any value of x. There's nothing magic about negative 2. When we substitute negative 2 in for x, we get y equals negative 4. That gives us an ordered pair of negative 2, negative 4. That's the solution of that equation. Now we pick another value of x. I chose to pick 0. When we substitute in 0 for x, we get y equals 2. That's another ordered pair, 0, 2. You probably already know that we only need 2 points to determine our line exactly, but we like to pick at least one more to confirm that we've done everything correctly, so I'll choose 1 for x. Substituting 1 in for x gives us 5 for y. Now we plot our three ordered pairs on the coordinate plane, negative 2, negative 4, 0, 2, and 1, 5. If we've done everything correctly, they should lie in a straight line. So now we connect the points with a straight line, using a straight edge, and also put arrows on each end of the line to indicate that the line continues on in both directions indefinitely. It's important to understand that there are an infinite number of possible ordered pairs that satisfy this equation. It's also important to understand that the answers are not just the nice integer solutions, like the ordered pair 1, 5, but also an infinite number of real number pairs that aren't integers, like 1/2 and 3/2, or 0.23 and 2.69, as just two examples. We can continue generating ordered pairs until the end of time and not finish. That's why a graph is so helpful, as it visually illustrates our answer in a way that tells us there are an infinite number of answers, and that if we could draw a graph big enough, we could always find any given answer somewhere on that line. Let's try another example. Again, we choose to solve for y because it makes it easier to generate our table of values, so we first subtract 4x from both sides. Then we divide both sides by negative 2, which gives us the equivalent equation y equals 2x minus 4. Again, I can choose any value of x I want, so I choose something easy like negative 1. When I substitute negative 1 in for x, I get y equals negative 6. Now I try 0 for x, which gives me negative 4 for y. I want a third point just to check, as the likelihood of making a mistake, such that all 3 points are still on a line, is pretty small. I choose x equals 1, which gives me y equals negative 2. Now we plot the points. Then we connect them with a straight line and add arrows to each end. This third example is a little different. Notice it's already solved for y and there's no x in the equation at all. Again, I can pick any x I want, so I pick negative 2. But in this equation, it doesn't really matter what I pick for x. Y will always be equal to 1. Now I'll pick 0 for x. But again, y is 1. Just to be sure I understand what's going on, I'll pick 2 for x. And y is still 1. We plot the points and notice that not only do they lie on a straight line, but that the line is horizontal. We connect the points and add arrows to the end. Any equation in the form y equal to a constant with no x at all is going to end up being a horizontal line through whatever that constant is, in this case positive 1. In the future, we could skip making the table and just draw the graph if we remember this. Notice in this example there is no y, only an x. Any guesses of what this line will look like? Again, we can make a table of values. This time, no matter what we pick for y, x will always be negative 2. When we plot the points, we notice that they lie on a straight vertical line this time. We connect the points and add arrows to each end. Any equation of the form x equal to a constant with no y will be a vertical line through that constant, in this case, negative 2. Again, in the future, if we remember this fact, we can skip making the table of values and simply graph the vertical line through the constant. This example includes a specified domain, or values that we are allowed to substitute in for x. Again, we can pick values for x, but this time we can only pick values that are within the domain of x greater than or equal to 0. So I pick 0, which is the smallest allowed value of x. For my second point, I picked a value of 1 for x. This gives me y equals negative 1 2/3. While this is a perfectly fine point, it sometimes can be difficult to plot something at negative 1 2/3. So for my next point, I'll pick 3, since I know that will multiply out the 1/3 in the equation and give me an easy point to plot. And while I have enough points, just to make it easier, I'll also pick 6, which also gives me an easy point to plot. I now plot those points, and I connect them. But this time I don't put an arrow on both ends because my domain is x greater than or equal to 0. That means that I actually have an array, sometimes called a vector, starting at 0, -2, and continuing indefinitely up and to the right. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step, I'm going to prompt you with the question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So for this problem, our first question is, what are we trying to do here? What we're trying to do is graph the equation. Your next question is, what's our first step? Our first step is to solve for y because that makes it easier to generate a table of values. How do we do that? We add 6x to both sides. Now what? Divide both sides by 2. What's our next step? We make a table of values. You could pick any values of x that you wanted. I chose -1, 0, and 1, but yours could be different. Now what? Plot the ordered pairs. What's next? Connect them with a straight line and add arrows to the end. Let's try another example. What do we do first? Well, that depends a little bit. You could make a table of values like this. Or if you remembered how to graph equations that look like this, you could have skipped to the next step. What is the next step? Plot the points. Then what? Connect them with a straight line and add arrows to the ends. If you'd remembered what a graph in the form x equals a constant looks like, you could have gone directly to graphing it. For this third guided practice, what's different? It has a domain, which restricts what values of x we can use. What do we do next? We make a table of values, making sure we pick values of x that lie within our domain. Then what? We plot the points. What's next? We connect our points, but we do not put arrows on both ends. Our solution is an array or vector that begins at 0, 1 and stretches up and to the left, with an arrow on that end indicating it continues on indefinitely in that direction. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problems on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video and work out the problem, then press play to check. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to graph a linear equation using a table of values. We did that by solving the equation for y, picking values of x within any specified domain, simplifying to get y, making a table of values, then plotting those ordered pairs and connecting them with a straight line. If no domain was specified, the line continues indefinitely in both directions. If a domain was specified, then the solution would not be a line, but could be an array or vector. There are other possibilities we'll explore in the future. Remember that you can always go back and replay portions of this video if you need to see it again.